First, we set up a 2D array maze. Then we start from the main function. Next, we begin the loop to search for the start location S. Once S is found, we invoke the Maze.walk function with the location of S. In the Maze.walk function, our ultimate goal is to find E, the exit. If the current location is E, then we return success. Else, we look for blank spaces to move into. First, we find that the current location is not E. So we look to the east and find that it is a blank. We leave a direction marker behind. Then we call the Maze.walk function recursively with that location. Note that the faded image of the bar represents the previous recursion of the Maze.walk function. In the new Maze.walk function, we first check to see if the current location is E. Since it is not E, we look in a square to the east. It is a blank, so we leave down a direction marker and call the Maze.walk function with that location. Then we start the new Maze.walk function by checking the square for E. Since there is no E, we look to the east. The next square east is a blank, hence we leave down a direction marker and invoke the Maze.walk function with that location. Again, in the new Maze.walk function, we first check for E. Since there is no E, we look in the square to the east. We find an X in the square, which is neither E nor blank. We cannot continue in this direction. We look to the north. We find that this is also an X, so we look to the west. It is the direction marker we left behind earlier, which is neither blank nor E. So we look to the south. There is no way to continue forward from this position. Hence, we put a blank in the current location and backtrack to the previous recursion. In this recursion, we have just only traveled east. This time, we will try north. In the square to the north, we find an X. So we look at the square to the west. We find a direction marker. Then we try to move south. There is also an X in that square. We cannot proceed from this position either, hence we move back to the previous recursion. From here, we look northward, since east is not possible. We find that the square to the north is a blank, so we leave down a direction marker and we call the Maze.walk function with that location. Following the same order, we start by checking for E. It is not E, so we look to the east. There is an X in that square, hence we look to the north. It is a blank, so we leave down a direction marker and invoke the Maze.walk function. Likewise, we check for E. There is no E. We look to the east and find an X in that square, and we check to see if north is possible. It is possible, so we leave down a direction marker and call the Maze.walk function recursively with that location. Generally, in the Maze.walk function, we first look for E in the current location. If it is not E, we look in a square to the east and try to look for a blank or E. If it is not possible, we try to look in a square to the north. Else, we look west, else south. If all directions fail, we backtrack to the previous recursion and start from where it left off previously. When E is finally found, the maze.walk function returns success back to its calling maze.walk function. The calling maze.walk function will then return success back to its previous calling function. And the maze.walk functions return success back to their previous callers until the very first of the maze.walk function finally returns success back to the main function. In the main function, since the maze.walk function is true, we skip printing the statement and jump straight to the print maze function. Then the print maze function prints out the maze and the program ends.